Assalamualaikum warahmatullahi wabarakatuh. So we are from group 2 and today we're going to presentate about unit process heat exchanger cell and tube. So let me introduce myself first. My name is Nusadi and my friends Harits M.Zaki Farilla, Raelda Kenan, and Hanif Zulkifli. So maybe we can go to the next slide. Yeah, those are my friends. So sorry. Okay. Um, the main topic that we're gonna discuss is about heat exchanger. Heat exchanger is a unit used to transfer heat between objects, both fluid and solid, in various industrial fields. Heat exchanger consists of various, namely cell and tube, double pipe, flat frame, and many more. So this is the picture of the heat exchanger cell and tube, as we can see right here. Uh, can go to other side. Okay, so in this presentation we have goals, we have purpose to reach. We try to find the thermal design, hydraulic, efficient mechanical cell and tube. Okay.
So, shell and tube heat exchanger is the most commonly used heat exchanger in the refining process of petroleum. Shell and tube is composed of a shell, which is a blanket tube, in which there is a tube. Generally, both have two different types of fluids, where the shell will be filled with a fluid with a relatively safer specification, with the tube is generally filled with a more extreme fluid. So this is the picture and working principle. So fluids with different initial temperature are flowed through each shell and tube. Then there will be convective heat exchange through the cell and tube walls that are in contact with each other as the fluid flows. To maximize efficiency, the design of the contact area must be wide. This is realized by making many tubes with smaller size so that the heat transfer process will be maximized. So there's types of fluid in shell and tube. Uh, Number one is fluid and liquid gas liquid, and gas.
Uh, Next up, selecting tube and shell material. First one is good thermal conductivity, then able to withstand high stress pressure, then resistance to corrosion. The example of shell and tube common material is stainless steel, titanium, fluorinide, ethylene, propylene, and then nickel. And the advantages of shell and tube, first one is cheaper than other heat exchanger. Then in operating unit framework with really high temperature and pressure, and the last one is relatively small pressure drop. The disadvantage of shell and tube is first one is having a small fluid tube capacity, then having complicated tube maintenance, and the last one is the effectivity of shell and tube is considered to be much lower than the other heat exchanger.
Okay, so for the process of calories transfer in shell and tube type of heat exchanger is convection. The types of flow can be determined based on the Reynolds of the fluid. So here is the equation to find the RE. Next. Global heat transfer coefficient is the overall value of the heat transfer coefficient contained in a heat exchanger, which is denoted by value of U. The value of U is obtained using the question shown here. Okay, next. Nip.
Hello.
Uh, can is my voice heard? Can you guys hear my voice?
Yeah, yeah.
Yes, yes.
Yes.
Okay, and next, finding RF. So we find the value of RF by using the equation below that is shown. Okay.
Okay, now we have the requirement that we need to find the heat transfer rate. So we must just use the equation here, key act, with the C heat or C cold, you know, or use the one equation in the bottom if we have the U. Okay. So the next is to easily calculate heat transfer rate. We need also heat capacity rate value using this equation too. This the scalar heat and the bottom is scalar cold. As you can see, we must also have the CP1. We must know that. Okay. For the next is we also must know the we must know the amount of LMTD, means logarithmic mean temperature difference, depend on what type of heat exchanger we are using. So the equation we use for shell and tube is, as you can see in the formula, we have multipass and cross flow, and then where the F is correction factor less than 1, and the delta T is counterflow, because LMTD counterflow. Okay. So the conclusion of this shell and tube heat exchanger is this type is the one with straight pipe shape, S shape, saving bevels with an area ratio of 20 until 25%, running with contact current flow and triangular tube arrangement, selecting of materials according to needs, selecting fluids with low flowing fouling factor, and filling the shell using fluids with relatively severe specifications. For example, the low fouling factor, low pressure, and temperature. While the tubes are generally filled with more extreme fluids, example Gretia, high fouling factor, high pressure, and temperature. So the heat transfer process that occurs in a heat exchangers includes one is convection on the shell side, and then also convection on the side of the tube, and then we have a conduction from the outer wall to the inner wall of the tube. So maybe that's all from the group 3. So for the next, I think I decided to our master ceremony.
Okay, thank you for group 3. Uh,